Analog comparators and op-amps can be used to make decisions, like turning on and off a light depending on whether it is dark or bright outside. In this video, let's understand comparator better. A comparator compares the voltage levels of two input signals and produces a binary output indicating which input is higher. A comparator, similar to op-amp, has two input terminals, one non-inverting input having plus sign and one inverting input with negative sign and a single output. If the voltage at the non-inverting input is greater than the inverting input, the output goes high, or VCC. If the voltage at the non-inverting input is lesser than the inverting input, the output goes low, or VEE. If we see the input to output voltage relationship of an op-amp or a comparator, we see a very high gain region for a small input range. In reality, if the input difference is few tens of microvolts, the op-amp will saturate to its power supply rails, producing a high or low output. Let's consider the example shown. If VIP is greater than 1 volt plus 50 microvolts, the output saturates to 5 volts. If VIP is less than 1 volt minus 50 microvolts, the output saturates to minus 5 volts. The linear gain range is just 100 microvolt wide, which is negligible in comparison to reference voltage of 1 volt. Since the input is analog and output is digital, either high or low, a comparator works as 1-bit analog to digital converter. There are two types of comparators based on signal inversion: positive or non-inverting comparators, negative or inverting comparators. Based on type of output, there are two types: open collector output and push-pull output. There are other types of comparators as well, like window comparators and hysteretic comparator. A positive comparator or a non-inverting comparator is a comparator configuration where the input signal is connected to the non-inverting input and the reference voltage is applied to the inverting input. When the input signal is greater than reference voltage, the output moves to high, or VCC. When the input signal is less than reference voltage, the output goes low, or VEE. The output is moving in the direction of the input signal, hence called positive comparator. A negative comparator, or an inverting comparator, is a comparator configuration where the input signal is connected to the inverting input and the reference voltage is applied to the non-inverting input. When the input signal is greater than reference voltage, the output moves to 0, or VEE. When the input signal is less than reference voltage, the output moves to high, or VCC. The output is going in opposite direction of the input signal, hence called negative comparator. Open collector refers to a BJT-based output where the output transistor's collector is left open and comes out as a pin. The emitter is connected to lowest potential. It requires an external pull-up resistor to create a logic high. This configuration allows multiple outputs to share a single line without drawing huge current from VCC. We will use open collector outputs to create a window comparator. In push-pull configuration, both push current transistor and pull current transistor are present. We have shown here some common push-pull stages. Push-pull outputs show significantly better rise and fall time due to unlimited supply of current. Please note that two push-pull output stages should not be connected together. Why? Let's see. In the left, we see an output node being shared by two push-pull comparators. Comparator 1 tries to assert high at the output. The PNP turns on heavily and NPN turns off. Comparator 2 tries to assert low. The NPN turns on and PNP turns off. One transistor is trying to assert high and another transistor is trying to assert low. Output VO cannot be determined reliably and a huge current flows through VCC to ground. In the right, we see an output node is being shared by two open collector outputs. Comparator 1 tries to assert high at the output. The sole NPN turns off. Comparator 2 tries to assert low. The NPN turns on. It draws only VCC by R current, which is limited by R. The output can go low without any problem. A window comparator is a circuit that uses two comparators having open collector output to check whether an input voltage lies within a specific voltage range, also called a window. A hysteretic comparator is a comparator circuit with positive feedback that introduces two distinct threshold voltages, preventing false triggering due to noise. Some common comparator ICs are LM393, LM311, TLV3201, etc. The internal circuit diagram of LM393 is shown here. Dedicated comparator ICs are better than op-amps for comparator applications. Many high-bandwidth op-amps draw a large current when a large differential input voltage is applied, hence not suitable as a comparator. Op-amps may show phase reversal. The recovery through saturation is poor. Comparators usually do not have these problems. The compensation capacitor in op-amp limits the rise and fall time. There is no such compensation capacitor in a comparator, so comparators have faster rise time for same power. Thanks for watching. Now you know what are comparators and how it works. If you found this helpful, give it a thumbs up, share it, and don't forget to subscribe for more such short analog circuit tutorials. Got questions or circuit ideas? Drop them in the comments. We'd love to hear from you.